Let's now consider integrating in spherical. This is the bumpy sphere that we talked about last time in the previous video, and I want to show you how to integrate the volume of it. Let's get rid of it for just a second though, and let's talk about something a little easier. Let's look at the basic sphere. So here's the unit sphere, a sphere of radius one-sided. Rho equals 1, and I don't really need this phi here. I was going to change it. Well, I guess this is how it's created. If you let rho be 1 and theta be 0 to 2 pi, and so this kind of explains what phi is all about. But regardless, let's just make it the whole thing. A goes all the way to pi. This is how you create the integration, and I'll show you how it's done down here. You just do int, and then you have your first integration, and then all the rest is pretty self-explanatory. You just keep adding int, and then what I do is I like to put a parenthesis around the variables, assign a phi. Sometimes it needs it and sometimes it doesn't, so I just go ahead and do it. So this gives you the volume here. Then down here, so as phi changes, the volume of it changes. We go all the way down, and then this is the area, the volume of the whole thing. So that's that. Now let's look at the snail shell object. This is kind of cool. Here it is. So it's rho equals theta, and essentially what I'm doing here is as theta gets larger, I'm building out this like snail shell. So it starts out really small, and then as it gets larger and larger, you see it's a snail shell. And then what this does here, this integration does, is it finds the volume inside of it. So I think this could be useful somewhere. And then if you want, we can look now at the notice what I did with the integration here. It goes 0 to b, so that b is the theta value. So as theta gets larger and larger and larger, we're calculating the volume inside the snail shell. All right, so in between each layer. So then now if we look at the bumpy sphere, the bumpy sphere, there we go. So here it is, right here. And then this, if I do the integration, then this is the volume of that bumpy sphere. And then as c gets, let z equals c, as c gets larger and larger and larger, z goes up. And so what this allows you to do is see it from the viewpoint of the cuttings of it, to kind of get an idea of what it looks like. It's just another viewpoint, that's all. So that's integration in spherical coordinates.